All right. Jonathan, can you see these pretty good?
Yes.
All right.
I can
You
zoom
might
up
wanna
on them.
Zero in on them. Jonathan, we are putting these in our Calc book. We left a spot for formulas. And here's a lot of the integrals that we've learned. The two on the top have been used the most, but these are going to come out and play as well today. So this is a review of all the integrals that we've discussed. And I'm going to show you a couple examples. How about, I don't know, what time is it? Maybe 3 examples, and then you're going to be working on the same assignment as was due today. So we're going to take another run at it. So we're just kind of fine-tuning our skills. So let's see if you can help me with that. Let's do one with, trig in it. When I see trig in this book, I say yes. I find that they're easier to do. They give you easier trig ones than they do algebraic ones. So I usually say this at the end of the lesson and they go right through. This one, however, takes a little bit of a trick. To find the integral of tan x dx, you have to remember a trig ID. So I gave you those, and I think you probably remember this one. Using sine and cosine, which I already have some information on, what is a trig ID that's equivalent to tan x? An old friend. I think you've shared it with us before, Gianni.
Sine x over cosine.
Sine x over cosine x. That should be embedded in your brain, at least for this year. Now, do you see the relationship? Is the top the derivative of the bottom? Yes. That's what we're always looking for, almost.
Do we have to take a negative one out?
Right, so we can put a negative. The cosine and the sine have a relationship. Is the top the derivative of the bottom? Well, the derivative of the bottom is, like you noticed, minus sine x. So I'm going to fudge it, put a minus sign in, correct my fudge by putting a minus sign out. So I haven't changed the value of my problem, but I've changed the form inside so that I can now take the integral. So the negative side comes along, and what do you think will follow? Aaron?
Would it be negative ln absolute value of cosine x?
Right, see how simple that is. If you see that the bottom is the derivative of the top, I'm sorry, that's wrong. If the top is the derivative of what's on the bottom, the answer is the ln of the bottom. So that's quick. All right, so that's that one. You can either memorize that relationship or you can actually remember how to do it. Either way, you need to be able to come up with the integral of the tangent when asked to. All right, we're going to do secant now. This is one that every year I teach that. It's been a few years since I've taught this. I have to look it up. I said, I know there's a trick to this one, and once I see it, I can do it. But the trick is you're going to multiply this by a form of 1, which you would probably not think of unless you've seen it. But I've seen it enough that I should remember it. It's secant x plus tangent x over itself. It's like, what? Who would think to do that? I had a former student come in at one time last year and ask me what's the integral of secant x. They were doing their college homework. And I said, oh, I can do this, I can do this. And I couldn't do it. I couldn't remember that it had a special, like I tried to write this as 1 over cosine and mess with it that way. So then I looked it up. I thought, oh yeah, I remember now. All right, why is this going to be helpful, do you suppose? Let's multiply out. Gianni, multiply out for me the numerators, and what do you get?
Secant squared x plus secant x tan x.
Now, does that ring a bell?
It looks like the derivative of the integration of tan x and secant x individually.
Is now the top? Is the top now the derivative of the bottom?
Isn't this where you can like pull?
See, here's secant x. What's the derivative of secant x? It's secant tan. See, the derivative of secant x is secant tan. What's the derivative of tan?
Secant squared.
It is. So it's just beautifully, if you knew that little trick, look how quickly it is integratable. So now the top is the exact derivative of the bottom. So Brendan, what's the answer when we have that situation?
ln
Right.
of secant x plus tan x
Right.
absolute value plus c.
Right. And again, you either memorize the integral of the secant or you memorize how to do it. On command, you need to be able to come up with this as the integral of that. It'll take a little bit of study, but not too much. All right, what else should I show you? I know, do you know how to do an integral on your calculator? Were you taught that last year? Do you have a calculator?
We weren't even
Out
allowed
there.
We weren't allowed to use our calculators.
All right, do you have one? Do you have one? Well, there are some cases, including like the AP test and placement tests, where you are allowed to use your calculator. So there are situations where you need to. You have one with you? All right, well, would you look
We'll
up together?
share.
All right.
Sharing with Karen.
All right. I'm going to do this next example by hand, and then I'm going to show you how to do it on the calculator, and then you can start
Fancy.
your assignment.
John, get out your calculator.
Yeah, get it out. All right. All right, your calculator is going to do definite integrals. That's where you have an upper and lower limit of integration. Like I'll have 0 and 4. And 5 over 3x plus 1 dx. So, all right, I picked this one because it's not particularly burdensome to do the integral by hand, so we'll go ahead and do that. So Morgan, is the top, well, I'll actually pull the 5 out. So, you know how 5s can run across the integral sign? So let's get the pesky 5 out of the way. So now Morgan, what is the derivative of the bottom?
3.
3. So I need a 3 up here in order to use this key integral form. So I'm going to put a 3 there. So what do I have to, how do I adjust?
1/3 on
Right,
the
so I'll just put under the 5, I'll put a 3. So now, Morgan, can you take the integral? Since the top is now the derivative of the bottom.
ln.
All right, and the
absolute
5/3 runs over
Oh, right.
long.
And then ln absolute value of 3x plus 1.
Right,
Absolute value plus 2.
all right. No, this isn't a plus C problem because we have limits of
Oh,
integration.
right.
So I'm going to put a 0 down here and a 4 up here. So, Erin, which one do we plug in first?
4.
All right, and minus the second one. All right, fine tune that. There's no plus C on this definite integral. So on your calculator, what is 5/3 ln of what, 13? Fine tune this term. Brendan, what's ln of, oh, I guess we don't know, we have to look it up. 5/3, so I guess you have to type through this whole thing for me. 3 times 1. So your calculator can get a decimal out of that, right? Oh, wait a minute. This is 3 times 0 plus 1. So we do know this. So Brendan, what is the integral? What's 3 times 0 plus 1?
1.
Right, so what's the ln of 1?
E.
No, ln.
0.
Right, okay.
Oh.
All right, so this whole term just zeroes out, so we end up with the ln of 13. So Brendan, can you get me the ln of 13? What decimal?
Oh, that's it, yeah. Where is that? Wait, ln of what am I doing? 13?
Mm-hmm.
2 point. Excuse me, she asked me. 2.6.
How come I got 4.27? Oh, because I did the 5/3. Now do 5/3.
Yeah, 4.27.
Okay. All right, now I want to show you how to do that whole thing on your calculator.
Like that.
So you go to the math menu,
Math.
and see the math button, and scroll down until you find an integral. What number is it?
9.
All right. So when you press 9, so most of us are 9, does the integral sign appear?
No.
What does it appear?
FN, INT.
Oh, fancy.
That means definite integral. Okay, show them what mine looks like. Who has a calculator like this? Everybody?
Me.
No, I have.
That's what I have as
I don't
well,
have the
like at
plus.
home.
And that's
Alright.
what fit here.
Ooh.
Yeah, this is snazzy.
All right, I'm gonna take a guess at your calculators. You can probably tell because you have a blinking spot, right?
Yes.
All right, so you can just fill in the 0 at the
Mhm.
blinking spot and just try to figure it out while I help them. I think on your calculator, it wants to know the bottom. If we get it wrong, we'll go back and change that. But you put in the first, you tell it 0 and then a comma.
I've never used the comma before.
Oh, here's your moment of
Where is it?
destiny.
It's the-
All right, now 4, it wants the lower
X.
limit of integration first, comma,
Enter.
the top.
Where's the comma?
Yeah. Do you want
It
to
should be
try?
a button.
No.
Have
It's
fun.
above the 7.
Oh, found it.
John, here's a view of the classroom.
Don't do that.
All right.
He's
Now
not gonna
you
watch
have to
it.
tell the calculator the function. Oh dear.
We're past 10 minutes, Miss Bell.
Oh well, we'll just keep
Just
going.
keep going? Okay.
All right, I'll turn it off after this problem. I think the calculator needs to know what the variable is. So you tell it x and comma, then you tell the function, and the function is 5
This calculator's
divide
really fancy.
3x plus 1, enter. And if it works, it's a miracle. Because I don't remember.
Error. Syntax.
Error.
All right, go back.
Whoops.
Go back and reverse this. Put the function
Error,
in first,
syntax.
then comma x. Reverse this.
Oops.
John, I don't know what calculator you have. So
I think he
we're-
has one like that.
Okay. So this didn't work, John. Don't try this. Anyone got their book with them?
Wait, did you say? Oh, okay.
Yeah.
Calculator book?
Oh,
Oh.
the calculator.
No, I
book.
thought
Oh.
it was
You
We
looked
don't
it
know
up
what
without your
he just saw the
calculator
music.
book? Oh.
Wait, so you put
I said-
0, 4,
That's what the
and then
internet is
5
for.
over
Exactly.
3x
Then comma x. Try it that way.
plus 1, comma, x. Error.
Oh.
All right, well, I'll have to look it up somehow online or something. It's something like this, but, sorry. But obviously that wasn't right. Did you get your mine to work?
Yes.
All right, did it give you 4.27?
Yes, I did.
All right, so mine is
Gianni didn't
self-explanatory.
want to
Mine
try that.
is easy to use. And once I look that up, I'll be able to help you with that. All right, so in the book tonight, it's gonna say, use your calculator after you do it by hand. Wait till tomorrow and I'll
Nice.
tell you how to do that. All right, let me give you your problems. We're on the same page. And that
Oh, I will.
page is 340.
I should be a cameraman. This is so fun.
I'll do 12 problems, so let's get started on them. We'll do 9,
9.
11, 13, 15, sort of coming alongside what we did
You're
last
close.
night with the odd ones, so you'll be able to check them.
Wow.
Okay, did you just get really excited that we want to check them?
10, 11, 12. All right, so let's work on those.
Should I stop this now?
All right, well, you make sure you can see the problem list there.
Yeah,
You can
I
see
zoomed
it.
up
Did you
on it
zoom in
good.
on it?
Yeah.
All right, Jonathan, that's all for today. No new material, just sort of more practice on finding integrals. So, hope you're okay. See you, hopefully, tomorrow. Be there. Bye-bye.